Hey guys, me again. So in this video, we're going to talk about problem solving with these volume formulas. And what we're going to be looking at here, your assignment is the tennis ball problem, which we'll look at in depth later, which is very, very similar to this first problem. And then the second one is also very similar. But let me see, where are we? We're going to start with this example. Allison makes a decorative glass sphere that has a radius of 5 inches for a friend. And so I'm going to go ahead and draw this out, and it's essentially a circle with a weird little smiley face on it to show that it's 3D. But you know what? We won't do that because that's difficult to do. There we go. And so that radius is 5. When we are doing problems like this, it always helps to sketch out a picture. Obviously, I don't expect you to sketch it out on the computer. You can have paper, you can have a little mini whiteboard, you can have whatever that helps you out. So anyway, that is the sphere. Then she wants to send it to this friend in a box that is 10 inches by 10 inches by 10 inches. And that's going to be like a perfect fit for this because if we're thinking about it, this is the radius. That goes halfway into the sphere. And it goes right to the center. And so this thing is probably going to be about as big as a basketball because all the way across it's 10 inches, all the way up and down it's 10 inches. From this diagonal over here, it's 10 inches going through the middle. So the box will be, let's see if I can make it work. Okay, so there's that one. And now let's see if I can adjust the size. Yes, I can. Most excellent. Okay, and I'm not going to spend too much time on this because I'm not going to nitpick and make your video an hour long. Okay, so there we go. There's the box. And the box is 10 by 10 by 10. And so it's 10 inches wide, 10 inches tall, and 10 inches deep. And obviously I didn't make this three-dimensional because that's hard to do on this particular program. And so the volume of this box, okay, fine, now I'm going to try it. Sorry. The volume of this box is going to be 10 times 10 times 10. Ah, look at me. So fancy. So fancy. There. Box. Horrible box, but there it is. So 10 by 10 by 10. Where's my little mouser? There it is. All right. And the sphere is that size. And so she wants to put the sphere in a box and wrap it up with packing foam. So that means that she's going to take those packing peanuts and she's going to stuff it in all of these little crevices that don't have, or that aren't, the ball. All that empty space that, the Amazon workers can kick around and damage her beautiful glass sphere. I'm kidding. Amazon's wonderful. So what we need to do to figure out what all this empty space is, we need to find the volume of the box and then take away the volume that the sphere is taking up. And so that's going to be our setup here. So we're going to say volume of box minus volume of sphere is packing space. And so that's the empty space that's going to be filled with packing peanuts. And so the volume of the box is going to be 10 times 10 times 10 because it's a rectangular prism, length times width times height. And then we're going to subtract the volume of the sphere, which was 4/3 pi radius, which is 5 cubed. So that means 5 times 5 times 5. All right. And then that's going to give us the space that is packing peanuts. And so 10 times 10 times 10 is 1,000 because I can math. But I can't math this whole 4/3 pi 5 cubed. So I still have my calculator up. So 4/3 times pi times 5 to the third power. And that's 523.6. So we're going to round that up to 524. Because on the other problem, we were still working with whole numbers. So 524. Okay, I got this. I think that's what it said. Yeah. Okay. And then that's going to be the space that is the packing peanuts. And so 1,000, oh, you know what? Let's just go back over here. Clear it all out. 1,000 minus 524 is 476. And that is in cubic inches, yes. Inches cubed of packing foam. So packing peanuts, whatever. All right. That's how we do this one. And the one that is in your homework is very similar, actually. The difference is instead of having one glass sphere inside a box, we're having 3 tennis balls inside a tube. And a tube is like this silly string. It's in a can, a cylinder. And so we're going to have to find the volume that 3 tennis balls will take up. All the tennis balls are the same size, in case you weren't sure. So we would take 3 times the volume of the tennis balls, and we would subtract that from the volume of a cylinder. Okay, so let's get back to that question there. Oh, look, the diameter's there. Excellent. We don't need diameter, we need radius, but we can figure that out from there. The can is a cylinder, and that cylinder is going to have the same diameter as the tennis balls. What is the volume of the space that is not occupied by tennis balls? And assume that the tennis balls touch the can on sides, top, and bottom. I love this question so much, because you have to figure out how tall is this can? How tall is it? Well, it's 3 balls tall. How tall is a ball? I feel like Dr. Seuss. Each ball has a diameter of 2.5. And now this again is where people think very linearly about circles and stuff. They say the diameter is just from left to right, right? Well, no, the diameter is also from up to down, or on this tiny slant that I have. Whenever you're slicing a pizza, every cut you make should be a diameter. See, there we go. All of those are diameters. They go through the center. And so if the diameter is 2.5, then that means that this can is 3 2.5s tall. But I guess what you really want to know is how do I find the volume of a cylinder? And that is something that we talked about last year in 7th grade. And so I will go ahead and give you that formula again for the volume of a cylinder. Yep. The volume of a cylinder, I need a text box, sorry. Volume is pi times r squared times the height. So let me make that a little bit bigger. That did not work. This does not work the same way that that my other program does. Okay, so the volume of a can is pi r squared times the height. And that's it. So once you know that, we're looking at the volume of the can minus the volume, minus 3 volume of tennis balls, because there's 3 tennis balls. Uh-oh. Let me put that over here. The volume of 3 tennis balls. If you know what the volume of 1 tennis ball is, then you know what the rest of them are too. All right, so I'm gonna walk away from that one because I feel like I'm holding your hand way too much, even though it's a video. Here's another one, and this one is a little bit more about displacement, but still similar. You place a steel ball with a diameter of 4 centimeters in a water-filled cylinder that is 5 centimeters in diameter and 10 centimeters high. So in this water bottle, if I plunked something in there and it was totally full up to the brim, then it would overflow because of displacement. And so what volume of water will spill out of the cylinder? Well, as much of the volume that is the steel ball. Do we really need to know about the cylinder? I'll let you think about that. So, those are your 2 problems for today. Please make sure that you continue editing or put your work on the same document that you have been working on. And I will see you later for the last video for this worksheet. And then we'll talk about magma. You guys have a great rest of the day, and we'll see you later.